Hello guys, welcome back to my YouTube channel, The Language of Gods, and I'm creating this video series where I'm covering some important concepts of Java language. And today's topic is immutability in strings. And you do let me know what you want me to cover in next videos, and I will work on it. If you are new to the channel, consider subscribing, like, share, and put your suggestions in the comment box. And let's get to the video. So guys, let's address today's topic in a different manner. What we'll do is we'll go through certain set of questions, and these questions cover almost all of the important concepts in the immutability of strings, and we will in the end we will go through certain other concepts which revolve around the immutability and will help you understand the topic even better. So as you can see on my screen, we have first question. Question is how many objects are getting created on line number 6. So the answer is 1, and let's see this in the OneNote. So to understand why there is one object getting created in this line, string x equal to t log, we need to understand what is string constant pool and what is heap memory. Whenever you see a string like this in double quotes, it is often created in string constant pool. So if you have a string like tlog within the double quotes, it is called a string literal, and all the string literals are given special place in string constant pool. And whenever you see strings getting created using the new keyword, those objects are created in heap memory. So instead of getting created in the string constant pool, when we are using this new keyword, these objects are getting created in the heap memory. But what is the heap memory and what is the string constant pool? So let's demystify that. Heap memory has an underlying data structure called heap, and heap generally looks like this diagram that I am showing on the screen. So heap memory has all the objects that are created at runtime and are created using the new keyword. But what about this? Is this tlog an object? Yes, this tlog is an object. It is a string constant, and it can be decided at the compile time, right, that this is going to be an object. So all the string literals are given special place in string constant pool. So as I already told, that tlog will be getting created inside string constant pool. String constant pool earlier used to be in a memory area called permanent generation, called permagen, but later they upgraded Java to use the string heap memory in the place of string constant pool as well. So both string constant pool and the heap memory are using the heap data structure underlying, okay? But string constant pool have special concepts, that the strings in the string constant pool do not repeat themselves. So this tlog string is going to be unique and only once available. So it is kind of a singleton that is available only once in string constant pool, and whoever wants to refer to the string tlog is going to refer to the same string in the string constant pool. And since strings are immutable, they even in fact all the references are pointing to the same tlog object. They cannot change it. Okay, so we are going to study that later, but just understand that strings are not duplicated inside string constant pool, and that's why it is used to enhance the performance, because you are referring to the same object. So you are not consuming more memory every time you are creating a new object. You are not pointing to the a new memory location with the same data. You are pointing to the same data and the same memory location in the string constant pool. Okay, but what is this x pointing to? So x will be pointing to the string tlog that is inside the string constant pool. Okay, so this is our first concept. Let's go to the next question and understand more concepts. So on my screen there is second question, and inside this question, the question is how many objects are getting created in these two lines, line number 7 and 8, and also answer is x1 equals to x2, or is x1 dot equals x2 is true or false. So let's see this question in OneNote as well. Let's number these lines as 1, 2, 3 and 4. How many objects are created on the first line? As you can see, we are using the both new keyword and the literal is also there. So tlog is the literal, and this new keyword will cause a new object to be created at runtime. So if you said 2, you are correct. So let's first create a tlog string literal in the string constant pool. And this new keyword will cause another object to be created in the heap memory. So x1, instead of pointing to this t-log and the string constant pool, will actually point to another object that has same data, that is t-log, but it is inside the heap memory. So x1 is pointing to this t-log, and this t-log is lying alone, and there is no reference to this t-log which is in the string constant pool. Okay. What about the line second? There is x2 reference getting created, which is pointing to another string created using new keyword. Since new keyword is used here, another string will be created with the same data as t-log, treating it as if it was new data. Although the data is same, but at runtime it is not known, right? So runtime will create another x2 object, and in the heap memory it will point to this t-log, and they will have different memory references. Okay, so let's say this has memory reference at 100 and this has memory reference at 200. So somewhere in the memory there are some memory indexes, right? So 100 is the index where this t-log resides, and let's say 200 is the index where this x2 resides. So this t-log resides which x2 points to. But this t-log on the line second will not be duplicated. So as we know, in a string constant pool, objects are not duplicated, but there is no reference to it. So answer is 3 objects will be created at just using line 1 and 2 when at runtime, but there will be no reference to this t-log. So you might wonder that will it be garbage collected? Yes, eventually this t-log can be collected by garbage collector, which is not guaranteed to run when, but eventually it will run. But if it runs immediately, the whole purpose of string constant pool will get lost, right? Because we want the performance to improve, and if the objects are not there in the string constant pool, or maybe later if we use intern method, we will not be able to just get to this t-log. So it depends on Java, how Java implements this garbage collection. It has to identify that sweet spot, maybe using the Bell's curve or whatever, just to figure out how much time the object should reside in the string constant pool. But that is not our topic. We need to know what is the string constant pool. So the question is x1 equals x2? As you know, when x1 is equated to x2, this can print true or false based on if they point to the same memory location or different memory location. So x1, as I already said, is pointing to the memory location 100, and x2 is pointing to the memory location 200. These two are pointing to different memory locations, so this line is going to print false. What about second line, x1 equals x2? So this equals method is special. So there is a equals method in object class as well, and string class also has equals method. Equals method in the string class is overridden, and is overridden to compare the actual contents rather than the object references itself. So if you get chance to look at the object class equals method, it is nothing but this line 3. So inside the object class equals method, it just compares if the x1 and x2 point to the same memory location. But this line 4 is calling the string class method equals, and x1 and x2, instead of comparing the references for them, the string class will actually compare the data for them. So it will cast the object into the string, and then string will be compared to another string in terms of data. So this line, although x1 and x2 are pointing to different memory location, this line is going to print true because they both have the same content t-log. I hope this made more sense. Let's move to next question. So before moving to next question, I would like to run this for you. So let me run it. And as you can see, it printed false for the first line and true for the next line. So as you can see on the screen, this question is a little bit more complex than the other ones, but if you are following along the other two questions, this should make more sense to you. So let's take this question into OneNote and try to answer it. So I have got the question in the OneNote. Let's number the line as 1, 2, 3 and 4 again. So on line 1, you have seen it already in the first example. So what will it do is it will create init reference, and this init reference is going to point to the t-log that is inside the string constant pool, because this t-log is a string literal and can be decided at the compile time. So string constant pool generally holds all the objects which can be decided at the compile time, and they are not going to change. And since string is immutable, this t-log is never going to change. So init can point to the t-log which is inside string constant pool. What about x1? Okay, x1 is another reference that is pointing to TL, which is very similar to line 1. So x1 is going to create TL. This line is going to create TL object, and x1 is going to refer to that TL in the string constant pool again. So line 1 and 2 are very similar. But what about line 3? Line 3 is telling that create a new string by combining the x1 and OG, that is another string literal. So as you know, string literals are created in the string constant pool. This line will again cause another string called with data OG to be created in the string constant pool, but there is no reference to it. Okay, after line 3 there will be no reference to this OG, and this OG will become eligible to garbage collection. But this x2, will it be solved at runtime or will it be solved at compile time? So as you can see, the x1 is not constant. The TL that x1 is pointing to is constant, but this x1 variable is not a final constant, right? It can point to any reference at runtime. So there can be any number of lines between line 2 and 3 which are, but there are no lines between line 2 and 3 right now. But it could happen in real world program that between line 2 and 3 there are multiple lines, and this x1 can change its reference to point to any other strings, right? So it is not guaranteed at line 3 that x1 will keep pointing to TL, right? So line 3 cannot be solved at compile time. Line 3 at runtime, when it will execute, needs to know what is the data inside x1 and then combine it to create x2. Even if there is no new keyword used over here, this x2 will be decided at runtime, and runtime calculations to create objects happen in heap memory. So x1 plus OG is going to be inside heap memory. And what it will be? It will basically be TL, because at line 3 the x1 did not change its reference and it is still pointing to TL. So TL will be concatenated with OG to create a string TLOG, and x2 will start pointing to it, and this string will be in heap memory and not the string constant pool. I hope it is making sense to you. Then the question is init equals to x2? So equals here is going to check the memory references and not the actual data. So let's say this is pointing to some string at memory. This x is pointing to some reference x2 basically. Okay, is pointing to some memory reference 100 which has data tlog, and this x init is pointing to same data tlog, but it is at different memory location altogether inside the string constant pool. So this x2 and init, although pointing to same data but are not pointing to the same memory reference. They are pointing to the string which has same data, but since the strings are residing at different memory location, x2 and init are not pointing to same memory location, causing this line to print false. Okay, so let's run this example and we should see false getting printed. Okay, cool. So let's move on to next question. So there is another question on the screen, the fourth question, and if you were carefully listening to the last question, you will be able to answer it out very easily. But if not, let's answer this together. So let's take this question in the OneNote. So I have already copy pasted this question to OneNote. Let's number the lines as we generally do: 1, 2, 3, and 4. What about the line first? Line first is again similar to older questions, and init is going to point to the string constant pool object, that is tlog. This x1 this time is a final constant, right? Even if it were not final, the x1 would have given a reference in the string constant pool, this TL inside, and the x1 will point to that. Okay, but the interesting line is the string x2 equal to x1 plus OG. What about this line, and what makes this line special? If you see on line 2, there is a final keyword. Okay, so I shortly covered this final keyword in the last question, but if you see what this final keyword and modifier is going to do, this is going to make sure that x1 does not change its reference for the whole lifetime of the program. So x1 is going to point to TL anytime at any point in time after this line 2. So anything happen after, let's say there is line 2 which is making x1 to point to TL, but there can be many number of lines, then another line at line 3, it is guaranteed that x1 will keep pointing to TL, because if you change the x1, this is going to be a compile time error, because you cannot change the references at which are modified using the final keyword. So at line 3, can we say that it is guaranteed to, the x1 is guaranteed to not change, and x1 is guaranteed to point to TL, right? So at compile time only, the Java is special and it is able to decide that x1 was going to be TL at any point of time. So this x2 can be resolved at compile time, right? Because x1 is not going to change, OG is not going to change. So x2, without any further thought, it will at compile time only decide that x2 is going to be pointing to x1, that is TL, and plus OG, so TL OG. And as you see, as we have discussed in the first question, the string constant pool has only one occurrences of a string and the strings are not repeated. So do you see that tlog is already existing in the string constant pool? And as we see, yes, it is. So TL plus OG will cause it to resolve to tlog, and the Java will check at compile time resolution that tlog is going to be already existing in the string constant pool. So this x2, instead of pointing to new string, it will point to the same tlog memory in the string constant pool. So until now, there is no object created in the heap memory, and all the 3 references are pointing to the objects which are in string constant pool. This question is again asking, is init and x2 are same? This time init and x2 both have the same data as well, and in fact they are pointing to same memory reference. So let's say in somewhere in memory indexing there is a 100th memory index and the tlog resides at that index. So this init and x2 are going to point to the same memory reference also. So this init and x2 are going to pointing to same memory location, which this line is actually checking. So line 4 is checking if they both point to same memory location. As you can see, yes. So this line is going to print true. But last time, since this final keyword was not there, it was printing false. So let's run this question and see if it really prints true. Yes, this is printing true, right? So let's move on to the next question. This question is very similar to the last question. So you should be able to answer it pretty quickly. What is init equals to x2 going to print at line number 9? But still, let me take this question to OneNote. So as you can see, I have already put the question in OneNote, and as we always number the lines 1, 2, and 3. Let's number them. And the first line is very similar to the old questions that we have seen. Init is going to point to the same string tlog. And line 2, what about this line? This line is seeing that tlog is a compile time constant. It is a string literal. OG is a compile time constant, is a string literal, and both are objects and are residing in string constant pool. So this TL is residing in string constant pool. This OG is residing in the string constant pool. Okay. Maybe let me put them this side. So TL is inside string constant pool. OG is inside string constant pool, but x2 can check that TL and OG can always be constant, right? They don't change their behavior because strings are immutable, and we are going to check that further in other topics that we are going to cover in this video. But since this TL is not going to change, this OG is not going to change, TL plus OG can be resolved by the compiler, and x2 is going to say to be equal to tlog. And is there a tlog inside string constant pool? Yes, it is already there. So x2 is going to point to the same tlog as the concepts we have studied previously, that the strings do not repeat, and this tlog is already there. So Java will check, is there some string tlog, and it will make the string x2 point to tlog. Okay. So when I keep saying this compile time resolution, you should know that it is still being done at the runtime, but Java somehow knows that TL and OG are string are going to be string that can be resolved compiler. So compiler itself can join these two string, right? It can create tlog over here. So it will basically solve this and put x2 equals tlog at the compile time itself, and later at the runtime x2 is going to be made to point to tlog. Line 2 will already have some line. When line 2 is getting executed, the line will already have been executed, right? So this tlog will already be in memory when the line 2 is executing, and line 2 is causing the x2 to point to tlog, and tlog is already in the memory location in the string constant pool. It will behave in this manner and will make the x2 point to the same memory location in the string constant pool. So this time also init and x2 are going to print true. Okay, so let's run this example in Eclipse, and if I rerun it, I am seeing true getting printed. So it is very similar to the last question. So now comes the main topic of this video, that is immutability. So we have built up our understanding of strings and strings, constant pool, heap memory. So let's address immutability in strings. So there are 3 points that one should know when considering the immutability in general, and the string immutability follows the same rules as generally the immutability concepts revolves around. So the rule number 1 is they should not, so immutability means immutable classes we are discussing here, and there are 3 points about the immutable classes that I wanted to discuss with you. They should not have methods that can change their internal state. So immutability means we should not be changing the objects once it is created, right? So if the class is going to be immutable class, it should not have any method that can change the existing state of that class, that object of the class, right? Okay. What is point 2 saying? Point 2 is saying that if they change the state of the existing object, so if there are methods that can change the state of the existing object, they should return new object without touching the existing object. Okay, so basically you are having utility methods in the string class that can appear as if they are changing the internal state of the string, but actually they are going to return a new string, and they are not going to change the existing string on which that method to change the string is being called upon. Maybe you can go back and listen to it again. Point number 3 is saying they can, and not should. I'm saying they can, and we are going to discuss this, why I'm writing this can over here. But I'm saying they can return the same object if the object does not seem to change after the changes. Basically, when we are calling any method that can change the state of the object, it will return new string. Okay, but in point 3, if they are not going to change, if the method does not seem to change, it can actually return a new string or may not return a new string depending on the behavior, special behaviors. But it is generally said if it is not changing the string, it can return the same string. Okay, and we are going to see that exceptional case in the end. So I have this main class which has 3 points, and I'm going to explain each point using one example. So let's go to first example, point 1. And what are we doing in this point 1? We are saying string x equal to tlog. We have already seen this, and we are calling x dot to lowercase and the replace method on the string returned by the to lowercase. So this to lowercase is going to return a string, and this replace is going to be called upon that string, and we are replacing the t with the capital T. So if you see these 2 lines, it could appear that this tlog is going to change to t lowercase, and that first letter of the string, it can find a small t and will make it capital T. So it can appear that this 16th line output could be printed on line number 14. So it could print tlog. But if I run this, you will see that instead of printing that, it prints the whole tlog object, right? Because line number 13 is not changing the original string x. This method is going to return a new string without changing this tlog, because the string are immutable and should not be changing the behavior as per the point 1. So this to lowercase will return a new string. Replace will be called upon that string that is going to be replaced, that is going to be returned by this to lowercase, and that replace method is replacing a character t with capital T. Okay, but it is not going to be referred anywhere. So whatever the string that is going to be returned by this method, there is no reference pointing to it. So it will eventually be available for garbage collection internally, but we are not going to hold that here. And this line is going to print the same X T log over here. Okay, I think this point is clear. Let's move to the point 2. So we have to just do what here is called the point 2 over here. Let's see what is point 2. Point 2 is saying if they change the state of the existing object, they should return a new object, which we were going to see here, right? So this time what we are doing, we are holding what was being written by the internal methods that appear to change the state of the string. So x.to lowercase and replace t with t would be returning some string, and that y we are holding. Question is this x and y going to be equal? If you said true, you need to rewatch this video from the start and come till this position, and you will be answering false after that. You should know that this method is not available at compile time, and compiler is not going to run this to lowercase, okay? Because this x is also not final, and the methods are not, even if this x was final, these methods are not run at compile time. They are eventually be going to run at the runtime. And this replace will again be run at runtime, and runtime strings are resolved in the heap memory area. So this y is going to point to string with which will have data tlog, but that data and that object with the tlog data will be in the heap memory area. But this x, as we have seen already previously, this is going to be in the string constant pool. So string constant pool, one is pointing to x is pointing to string constant pool, y is pointing to the heap memory area. Are they going to point to same memory location? No. So this line number 22 is going to print false. What about line number 23? Line number 23 is going to print y, which is basically the operated upon version of the x, replace with 2 lowercase and replace t with t. So y is going to print capital T and small log. Let's see that. So you can see first line printed false because of different memory location, and y printed tlog because we are holding the changes on the string that are happening upon the new strings getting written by the the methods that are modifying the internal states, but it is not modifying the x, the first string itself, but it is creating a new string every time we are calling this utility method to change the state of the string. Let's go to point 3. Okay, so let's run this point 3. But before that, let's see what line point 3 is telling. So what we are doing is we want to run this first use case. Okay, we have already seen tlog, and we are calling to lowercase. Will it be returning a new string or old string? As you see, to lowercase is operating upon this. So at runtime it will be returning a new string, you may say, but if you see point 3, it is saying it can return same object if the object does not seem to change afterwards. Is this to lowercase going to affect this string? No. So Java has a special knowledge that at runtime it will see, okay, tlog is the same string and it is pointing to the same string constant pool, and to lowercase is not changing the data of the string. What it can do is make the y point to the same memory location in the string constant pool, and wonderfully x and y are going to be equal this time in terms of data and in terms of memory locations as well. So if I run this, you will see true, right? Okay. Why this third point has can and not should? Let's answer that now. So I said that there are some methods which can actually not change the data in the end, but logically they will operate upon the string and will return a new string with the same data. Let's see first example. What we are doing here is, so we have a string a pointing to tlog, which we have already seen. This tlog will be in the string constant pool. A dot replace t with the t. This t is replaced with the same character. So this replace method is special. It has knowledge that you are replacing the character with the same character, right? These two are equal. It will not change this tlog. So this replace method, although appear to change the t with the t, since it is not going to impact the tlog, it is not going to create a new string, and the b will point to the same memory location in the string constant pool that A is pointing to, because A dot replace actually returns the same memory location that A is pointing to. So if I run this, it will actually print true, right? It is going to print true. But what about third one? Third one is special. Third one is taking string. Basically it is a method that takes character sequence. So it could even take string builder that you can think about later, but this string is TL, this string also TL, basically a character sequence. And this replace method at runtime also does not checks if this string is equal to this string or not. So whenever this tlog will be changed using this replace method, although it will find that there is a TL, it will replace the TL with the TL. Okay, so it will replace the TL with the TL. The string data will be same, but since it is actually going to replace that data in the string, it is going to create a new string with the another data with the same data. So if I run this, it is going to print false. All the data is same, but this replace method actually will change the string and will change the TL with the TL. Okay, if I change this to something OO, it will print false again. But what I want to do is print this B2. So this B2 is going to print OOOG, right? Because this replace method is actually changing the TL with the TL. Okay. Let's look at one more question and let's understand what this one more topic, and let's understand what this intern method is. So I have named this class as intern, and we are going to see what intern method is. So when we read the intern method, we should see this Java doc. It says when the intern method is invoked, if the pool already contains the string equals to this string determined by the equals method. So if the pool has the string with the same data, so equals method we can call on that string, and if the string constant pool already contains a string with the same data, then that string is returned, the memory location of that string is returned, which can be pointed by the reference. But if the string is not already there, so that there is no string with that data in the string constant pool, it will going to create that string in the string constant pool and will return the memory reference of that. So it is guaranteeing that whenever you are calling that intern method, it is guaranteed that your string referred by your reference is always going to point to the string which is in the string constant pool. So let's look at this example. What it is doing is init tlog, we have already seen this, string x1 equal to TL, again we have seen this, it is in the string constant pool. This x2, is it going to reside in the string constant pool? No. We have seen that this line is going to cause x2 to be solved at runtime, because this x1 is not a final constant. So this x2 is equal to tlog is basically a heap memory area object x2, but init is a pointing to string constant pool. X2 is pointing to heap memory area, different object altogether. What is this going to print? If I comment this and I run it, it is going to print false, as we have already seen this. But what if I uncomment this one and I comment the first one? The first topic that the first logic that intern method says, if the tlog, as you can see on line number 8, it is already there, right? Tlog has already been assigned in the string constant pool, and init is already pointing to that. So it is guaranteed that it has not been garbage collected yet, because there is a init variable in the lifetime of the program. This x2.intern is going to search if the tlog data string is with search using the equals method, and is this tlog available in the string constant pool? If it is available, it will return the memory reference of this init itself. So this intern is going to point to the same memory location that this init was pointing to, because this is the logic of intern method, and it is actually native. See, if I go inside this method, there is no implementation. Okay, so if you want me to cover the native methods, we will cover that in another video, but just know that this intern method, how it behaves. So this is going to return true this time. Okay, true. This is the first concept of intern method. What about the second concept? What if it is not there in the string constant pool? So as we saw in the documentation, it is going to put that in the string constant pool and is going to return that. So this string a equals TL, we have already seen this. It will be pointing to the string constant pool area. Okay, this a is going to point to the TL. This y is at runtime going to be merged with a is going at runtime will be merged with TL. So this is going to create a new string that is tlog, but still it will be at runtime, it will put using the intern method. So until this, at this line, there is no tlog existing in the string constant pool because all other lines are commented, and this line 17, it is going to search inside the string constant pool that is tlog available. So tlog string data is not available in the string constant pool. So this intern method is going to put that in the string constant pool, and y is going to refer to that string constant pool. But at line 18, this tlog is going to be available first, and as Java sees this tlog that I am highlighted right now, it will check if this tlog is inside the string constant pool. Yes. So this tlog is nothing but another object that is the same string constant pool object. So this is again object which is reference to the same object tlog, and y is again the same memory location object, object that is at the same memory location that this tlog is pointing to. So this intern method has already put that in the string constant pool and has returned y. So this is going to print true. Let's run it, and as you see, it printed true. Let's move on to the last topic of today's video, and let's move on to the last topic of today's video, and it is a special question that I have prepared especially for you. So let's answer that. So what we are doing is seeing that how immutability behaves over here, okay, and also how Java is a pass by value language, not a pass by reference. And if you want me to cover this pass by value, pass by reference, please put that in the comment section, and I will create a small video on what is pass by value, what is pass by reference in Java. And it is very important that you understand it. So if you are able to understand, this video is enough for you to understand what is pass by value and pass by reference. Let's see at line number 6, string x1 equals false. Okay, understood. Change x1. What this change is doing? Change can accept a string and pass by value. So this x2 is going to point to the same value, and the value that is passed inside the method is the memory reference itself. Okay, so if we want to see in OneNote, let me quickly show you. So I have already put the line, first line, string x equal to x1 pointing to the false in the string constant pool. What about the change method that is accepting? It is accepting x1 and the same memory reference. So memory reference of x1 is going to passed here in the change method. So memory references are passed. So x2 will receive the same memory location to point to, and it will point to the same false. It will not have the same data, and it will not be like the data is passed. It is a pass by value, not pass by reference. Although it may appear that you are passing the reference, but the value of the memory location is passed, and the value is the same memory location. So again, it start pointing to the same memory location. What about this line number 17 inside the string, inside the change method? It is making x2 point to true. As you know, the strings are immutable. This link, this special link that we have created will be broken, and a new link will be created that will point to the true, and this true again will be in the string constant pool, as you have already seen multiple times now. So this link does not exist anymore. So x1 and x2 are made to point to different memory location in the string constant pool. But when we print x1, x2 has already lost its lifetime, and after this x2 is eligible for garbage collection. So this x2 does not exist after this scope of this method. So line 8 is going to print what? So as you can see, we have made the diagram. The x1 is still pointing to false. So it may appear that you are changing the x1 here, but it is not changing the x1. This x2 will be pointing to that new true object getting created in the memory string constant pool. So this x1 will not change. So if I run it, it will still point to false string. Okay. What about another concept? And it is important and a special one where we are using array. So we have created xa1 equals array, and we have this array false having one element only, that is a string with data false. What about this change method? Change method is a pass by passing is accepting an array of string, and we know that Java is a pass by value and not pass by reference. So what about this? So let's take this to OneNote as well. So this xa1 will have array memory in the heap memory, or the special memory allocated to create the array, but it will not be string constant pool. And there is a 0th index. There are no more indexes. There is only one index, that is 0, and this 0th index is pointing. So I am creating this diagram for you to understand that this 0th index is pointing to a string that is inside the string constant pool. Again, because this false was a compile time constant that was understood by the compiler, so it was eligible for putting in the string constant pool. So this array with 0th index will point to this false. Now what we are doing is passing this array to a change method. So this x2 will receive the same memory reference to point to. So I will create this x2 variable over here, and it will point to the same array. Okay, it will point to the same array. The memory reference value will be passed, and now it is saying that change the x2 of 0 to true. It is saying make this 0th index point to something else. So x2 is not changed. Okay, x2, whatever x2 is pointing to, it is not changed. It is changing what x2 array's 0th index is pointing to. So again, so this link will be broken. This link will be broken, and a new link will be created over here pointing to a new memory location with with data true, and again that will be in the string constant pool, because true is again a compile time constant. This false is eligible for garbage collection. Okay, so this false you see is eligible for garbage collection, but this true will not be lost. This true will be kept in the memory even if the method has returned. So even if this method has returned this one, this true will be kept in the hold, and at line number 11 this x7 has already been changed, so this will actually be printing true. Okay, true. So this is a special one when we are passing string array, when we are passing string. So with this, our immutability concept in string is over, and I wanted to add further more along the string builder classes, string builder, string buffer class, and string class. So as you can see on my string, I want to cover another video, create another video where I'm using all these methods and solving concepts on them, and also string class methods. So there are a lot of string class method that I want to cover, and in a very effective manner. So please put that in the comment section if you want me to cover these string methods, and with that video, if you want me to cover it, will cover everything that is asked in interviews, that is asked in Java certification exam, and even when you are developing your code in your work life, you will be able to do that even more effectively, because these methods you have to learn them by heart. Their string is the core data type, right? Because all the language that we talk, whatever we speak, we write, everything is eventually going to be stored in string if you are in Java, right? So did you like this video? Put that in the comment section, let me know. I will create new videos, and for the time being, see ya, all the best.